when it comes to the unfortunate part is we have to do one extra step, and we'll talk about that in a little bit. So the next case of scenarios is radicals, meaning just, again, fancy word for saying we have square roots, okay? And when it comes to this type of, it's going to look like this. So we have a radical, we have variables inside, numbers on the outside. So when it comes to these ones, again, we have a little bit of steps to help you guys out when it comes to it. But again, it kind of follows the same thing we did last time, okay? So the first thing you always want to do, and this is the most important one, is always isolate the radical. What that means is you want one side to have numbers, on the other side just have the square root sign. That's what that means, okay? Step two is we're going to raise both sides to the power to cancel each other out. So if it's a square root, that means we're going to square both sides, meaning everything raise it to the second power, okay? If it has a 3, so if you have a question like this on your quiz, kind of like that, you would raise it to the third power to cancel that. That's what you mean by you want to raise it to the power in order to cancel it. Okay, so you have to raise it that same power you have it there. So again, for example, if it's the 4th here, you would raise this number to the 4th power to cancel that out. Okay, so that's what that means. And mostly it's just going to be square roots. It's always going to be squared. But on the rare occasion you have different stuff like that, you would just raise it to that power itself. Okay, so that's what that is. And then step 3, you just solve for the variable. And the key thing that's very, very important, believe it or not, is we actually have to check if it actually works out. Because there'll be some indications where it actually doesn't. And that's the horrible part, because you did all this work and you find out that the value you got doesn't actually work. Okay, and it means, and whenever we have one value that doesn't exist, we just say no solution. And again, I'll give you guys an example of that in a little bit. Okay, so here we just have a quick little example of going over exactly what I just said. So let's suppose we just want to solve for this scenario. So step 1 is you just want to isolate this, meaning you want only this on one side of the equal sign, meaning we're going to get rid of the first, get rid of this first. So we're going to subtract it to both sides. So once we isolate it, now we're just going to square both sides. That's the only way to cancel the square root. So again, those cancel, and we just get what's everything on the inside. So 4 squared is just 16. And now notice, now it's nice and simple, right? Add 3 to both sides, and we're done. And then finally for step 4, we just got to check. Now again, well, let's see. Well, I don't want to say too much, but let's say like 95% of the time it's going to work, but there's always that 5% chance it won't work. And you never know. I might give you that 5% chance just to see if you guys are paying attention. So just, be careful, that kind of stuff. But in most cases, it will work, but, just in case you got to check. And what by checking is, all you're going to do is plug in 19 in for x and see, does it work out, right? So if you do all this fun, does it actually equal 13? That's all we're really doing is checking. So plugging it in. So oh yeah. So we just plug it in. Oh, this is supposed to be a 2. What am I messed up there? There you go. Okay, I got 2 up. So 19 minus 3, that gives you 16. Square root of 16 is 4. And then 4 plus 9 is 13. So check, it works out, right, when it comes to it. So that's the final thing. It's just a quick little check. It only takes like 30 seconds at most to do, but it's very, very important when it comes to it. Okay, right. So let's see an example so you can see how this is going to go about, right? So again, I'll give you guys an easy one, a medium one, a little bit more difficult one, and a trick question one. That way you guys have all 4 scenarios you can be dealing with when it comes to it. Okay. So let's, for each one again, we're going to be solving. So for the easy one, again, we're just going to do a medium-sized one. You guys will see roughly to deal with, kind of like that. So let's suppose we have this. Okay. So same scenario as above. We want to isolate the radical, meaning we're just going to get rid of this first. So minus 2, minus 2. That gives us 6. So if we just mimic what we did on top, all right, so we isolate it. So now we go on to step 2, which is going to square both sides. We're just going to square both sides. So these cancel, and we're just left with everything on the inside. And then 6 squared is just 36. And now notice it's beautifully nice to solve for, right? This is what we want to go for. So in this case, we just quickly finish it up. So we're going to add 5 to both sides. That gives us 41, dividing by 3. And I don't think it goes in evenly, but I could be wrong. No, it doesn't. So 41 over 3 is our answer. Okay. And then lastly, we just got to check. Now, holy moly, I have to plug in a fraction. Trust me, it actually ends up pretty nicely. So we just check, right? So all we're going to do is check and see, does it actually work out? So if we just plug it in, so it'll be 3 times 41 over 3 minus 5 on the inside plus 2. And we're going to see, does it actually equal 8, right? We don't know yet. Hopefully it does. Now, the reason why I say don't worry, it's a fraction, look what happens here. This 3 and that 3 actually cancel. So this ends up being just 41 minus 5 on the inside. And again, we're going to see, does it actually equal 8? So 41 minus 5 gives you 36. And the square root of 36 is 6 plus 2 does give me 8. So it works out just like that. Any questions here at all? No, not too bad. Okay. So if there's no questions, right? So now let's go to a little medium one, a little bit more difficult. Again, what I mean by difficult, just a little bit more work, right? Nothing too big deal. So let's try, should we try? Let's try this one. All right, well, step 1 is already done for us. It's already isolated, which is even better. So step 1 is done, check. Step 2, we want to raise everything to the power. So we're going to square both sides, but this time we're squaring all of that. Well, these cancel, and we just get 4x plus 13. However, on this side, unfortunately, we have to FOIL. Because remember, this means we have 2x minus 1 times another 2x minus 1. So that's what I mean by it's not more difficult, it's just a little bit more work. That's all it really is, right, when it comes to it. So let's just FOIL, and then just go from there. So this is going to be 4x squared minus 2x minus 2x plus 1. Right? So if we plug this in, this is going to be 4x squared minus 4x plus 1 on that side. And now we do the same thing we did last section. Bring everything one side, and guess what? Solve again. Right? So subtract 13, subtract 4x. So we get a big fat 0. And we get that on this side. And now again, we just solve. So again, you can either use the quadratic formula or factor. Hopefully we can factor when it comes to it and be done for there. So I'm going to try factoring. If not, we'll just use quadratic, but let's see if it does work out. It's negative 8 on the bottom. 4 times 12 is negative 40. What is it? No, it is 48. And let's see what we can do. Two numbers when you give you 48, add up, give you negative 8. Anybody have an idea? Is this possible? Negative 12 and 4. Oh yeah, exactly those, right? That's nice, right? Good. Adam. Oh, perfect. Even better. And since we do the snowflake method, this is 4x and 4x. So our factors are x equals 4x minus 12 and 4x plus 4. That's kind of nice. And again, right, since we're solving, set each one equal to 0 and just solve for x individually, just like we did, you know, all pretty much all day today. So simplifying each one individually, this gives you should be x equals 3 and x equals negative 1. And then lastly, we just got to check. So this time we got to check two answers. So we have to check if x equals 3 works and x equals negative 1 works. Again, all we just do is just plug it into the original function. So we got to check if I plug in 3, so 4 times 3 plus 13, does that give me the same thing if I plug it on the other side, right, when it comes to that? Then we just simplify, right? So 4 times 3 is 12 plus 13. Does that give me 6 minus 1? So this is 25 and this is 5. And yeah, right, square root of 25 is 5. So that works. Perfect. And now we just check again for x equals negative 1. Right, so 4 times negative 1 plus 13. So does that equal 2 times negative 1 minus 1? So inside here, it's going to be negative 4 plus 13. On this side, it's going to be negative 2 minus 3. Oh, sorry, what am I doing? Minus 1. Inside the square root, negative 4 plus 13 gives you positive 9. And on this side, that gives you negative 3. So if I take the square root of 9, does that give me negative 3? Hopefully you say, what? No, right? Because this equals positive 3. So they don't work. So if we go back over here, our true answer is only x equals 3. So that's why it's important to check, because actually one of your answers may not work, or both answers actually may not work at all. So this one doesn't work. That's a true answer there. Any questions on this one at all? So all good for this one? Okay. All right. Let's do one more. So one very similar to this one. This is probably the most difficult you'll see anyways. Let's try this one out to finish up. So very similar to what we just had before, right? The only difference is we have this minus 6, right? That's the only difference between this one. So therefore, we do actually have to do step 1. So step 1 is to isolate it, meaning to get rid of this. So since we're subtracting it, therefore we have to add 6 to both sides, right? And that's how we isolate it. So that ends up being negative 5. And now notice, now it's the exact same scenario we had earlier. So that's what I mean by it's not more difficult, it's just more work. That's all it really is. So what what's the difference between a kind of easy problem and intermediate and difficult problem? Is just the length of the work. It's not really that difficult to do, right? When it comes to it, just could be kind of tedious. Right? So we go on to step 2, which is going to just be squaring both sides. So on this side we get 4x plus 5, and again on this side we're going to have to FOIL this out. So let's see when we FOIL this out. Gives us that. Okay. All right, and now we just bring it over. So subtract 5, minus 4x, minus 4x. And we do the same scenario we had previously. Oh, no, this is wrong. This is a positive 5. No wonder it's a little off. This is now 20. There we go. Yeah, negative makes positive. Yeah. Sorry about that. That should be positive 20. There. So, second to last extra credit for today. Go ahead and finish it up. What are our 2x values? And after you check it, which ones actually work? Go for it. there's your hint if you get a little stuck on there. Keep going if you guys aren't finished. Remember, this is for extra credit. Anybody get him? Almost done? You guys finished checking? So do they both work or one works? What do you guys get? Okay, so if we just check them, right, go back to the original. So -1 doesn't work, or sorry, 1 doesn't work. So we'll check if 5 works. So 5 works, right? So only 5 is our answer. So not -1. Okay. So any questions on solving for radicals, so square root stuff at all? So everybody comfortable? Okay. Okay. So the last scenario we're going to talk about is actually the easiest of them all. Good thing, right? I'm sure you guys are telling like that's a lot of work. And the reason why it's the easiest of them is because it's very, very similar to what we've done already, which is, again, one extra step. So what if we don't have x squared, but x to the fourth in this case? Okay. So whenever we have this situation, we're literally going to do the exact same thing as if it was just x squared, meaning just factor. Now, I'll give you guys a hint. When it comes to these type of scenarios, factor will always be the easiest to deal with. Okay. And what I mean by that with extra step is we'll just go through the motions and you literally just factor the same way we've done so far, just like we did the last one. So 3 times 2 is 6, 5 down here. Okay. So therefore, these two numbers would be just 3 and 2. Okay. To the portion, this is now 3. Now, it's the only difference now becomes is instead of just 3x, it's 3x squared, because that's the inner term we have. That is the only difference between these type of scenarios and when it was just single x squared. Okay. And we keep doing the same thing. So this is going to be 3x squared plus 3, and then 3x squared plus 2 equals 0. And again, we just solve individually. So bring it down here, it's be 3x squared plus 3 equals 0, and 3x squared plus 2 equals 0. And then we just solve for x individually. So bring this over, minus 1. Same thing over here. Okay. And now divide both sides by 3. So we get x squared is equal to -1/3, and x squared is equal to -2/3. And then lastly, again, the only difference is we want single x, so we just take the square root of both sides. Now, this goes back one section. Remember, when we take the square root of a square, we get the positive or the negative. So we're going to have actually 4 answers. So positive of this one, the negative of this one, and same thing applies on the other side. So now we get our 4 answers there. But it's very, very similar just if it's just x squared. The extra step is literally just that portion there. And that's it. That's what I find is one of the easiest ones to do of the 3 when it comes to it. Right, so any questions there to finish off this section? All good? Okay. All right.